So let's get started with the third lecture of algebra modulus function. We have already studied binomial expansion. This is the third lecture and the final lecture of modulus, and we'll be focusing on some past paper questions from the topical book. That is where we are looking at page number 73, exercise F. This is modulus 2. Modulus 2 is P3 past paper questions. Let's look at question number 1. What is the rule? We will decide on the case and then we will solve it out. So now there is modulus on the left hand side. There is modulus on the right hand side. So this is case number 3. This is modulus on both sides. What is the strategy? The strategy is square both sides. And you actually square both sides and you solve. So therefore x minus 4 the whole thing square lesser than 2 bracket 3x plus 1 whole thing square. This is x square minus 8x plus 16. I expanded the left hand side. And then we have 4 multiplying with 9x square plus 6x plus 1. Go very easy, go very gradually on it. So this is x square minus 8x plus 16 is lesser than 36x square plus 24x minus plus 4. I'm just thinking one step ahead that I'm transferring to the other side. So you have to control your emotions. So now x square minus 36x square, that is negative 35x square, and then negative 8x negative 24x, that is negative 32x, and then 16 minus 4, that is plus 12. This is lesser than 0. Now the rule is make sure the coefficient of x square is positive. So we will write this thing as 35x square plus 32x minus 12 is less than 0. So now if everything is all right, because sometimes you get unusually large numbers, so there is no harm in double checking. This is a square minus 2ab, 2 into 4 into x plus 4 square. This is perfect. 3 square is 9, 2 into 3 is 6, 1 square is 1, 4 9s are 36, 4 6s are 24, 4 1s are 4. All good. 1 minus 36 is negative 35, minus 8 minus 34 is negative 32, 16 minus 4 is 12. I think this is all good. Now let me grab my calculator and let me multiply. So I'm just using the basic thing. That is, that's this new update. I'm just trying to figure it out. Which way should I go? Okay. So now this is 35 into 12. It looks good than before. That's 420. So now that's a good number. 420 is 42 into 10. So therefore this is 35x square plus 42x minus 10x minus 12 is less than 0. So therefore I'll take 7x common out. This is 5x plus 6 and this is 2 common out. And this is 5x plus 6 is lesser than 0. One thing that I missed, which I shouldn't, that is flipping the inequality. When I change with a negative sign, the inequality flips. So multiply both sides by negative 1, therefore inequality flips. Inequality flips when coefficient of x square was negative and we made it positive. So that is the notes that you need to understand. Now let me proceed with this. 5x plus 6 bracket 7x minus 2 is greater than 0. So now draw the x-axis. Draw a curve like this. Mark the roots. This is positive 2 over 7. This is negative 6 over 5. You can just do it visually. And it's greater than 0. So if it's greater than 0, that is this region above the x-axis, this region above the x-axis. So therefore, which way are we going? I'm just very particular about shading. We are going to the right, we are going to the left, because this is two separate regions, two separate answers. So therefore, the answer is x is greater than 2/7 and x is lesser than -6/5. Now let me illustrate this on the graphical application also. X minus 4 modulus 2 bracket 3x plus 1. So there it is. The first one is y equals to modulus x minus 4. So this is x minus 4. That's the first equation, the green one. And the next one, that is which one? That is 2 bracket 3x plus 1. 2 bracket. So this is y equals to 2 is on the outside modulus, and this is 3x plus 1. 3x plus 1. If I'm not mistaken, that's the one. 2 bracket 3x plus 1 and x minus 4 modulus. So there it is. These are the points of intersection. And again, let me take a screenshot. Let me just save it, copy it. X minus 4, 2 modulus 3x plus 1. So this is x minus 4 bracket 2x plus 1. Let me double check. X minus 4 is lesser than 2 bracket 3x plus 1. So the x minus 4, that's the green one. X minus 4 modulus is lesser than the blue one. 2 bracket 3x plus 1. How would you translate it? The green one is below the green one. This is the blue one. The green one is below the blue one. So these are the points of intersection. That's one of them. That is the other one. And over here, this one is 2/7. Of course, that's not exact. Hold for a second. So that is one value. And this is the other value. What are these values? One of them is 6/5, which is negative 1.2, and this is 2/7. So this is negative 6/5. This is positive 2/7. The green is below the blue. So green is below the blue. That is to the left of this, and that is to the right of this. So this is all good. This answer makes sense. So I hope those people who are watching this, they're all good and clear about it. All good? So this is just to give you a good idea graphically how it looks like. It's not part of the solution. Let me remind you, this is not part of solution. This is something extra. So this is just extra stuff. Why? Because we are just solving it algebraically, which is a very nice and neat way of solving it. So this is all good, all clear. So 4 stars for this. All good? So now let's move on. Let's look at this question. Now this one you have to solve it algebraically because nobody will take the value of a. State the set of values of x satisfying this inequality where a is a positive constant. X plus 2a modulus is greater than 3x minus a modulus. Again, square both sides. So when we square both sides, what happens? X plus 2a, the whole thing square, is greater than 3 bracket x minus a, the whole thing square. That is x square plus 4ax plus 4a square is greater than 3 square becomes 9. And this is x square minus 2ax plus a square. I just want to double check one of my working. Did I square the 3 on the outside and the 2 on the outside? Yes, I did. The 2 square becomes a 4. Just wanted to double check. So this 3 after squaring becomes 9. So now let's simplify. This is x square. This is 4ax plus 4a square is greater than 9x square minus 18ax. and this is 9a square. So this is x square, this is 9x square, that is negative 8x square. Then we have 4ax, this is negative, going to the other side becomes positive. So therefore this becomes 4a plus 18a, that is the coefficient of x. And then we have 4a square, this is 9a square, this plus taken to the other side, that is negative 5a square, and this is greater than 0. Now multiply throughout by a negative sign, so therefore this is 8x square, this is negative 22ax, and this is positive 5a square is greater than 0. So now focus on this. This is 8, this is 5, that is 40, and this is negative 22, which is 20 into 2. So 8x squared minus 2ax minus 20ax plus 5a square is greater than 0. Okay, again I forgot to flip the sign, so that is a mistake that I make. So that is why rechecking is very necessary. Lesser than 0, lesser than 0. It was greater, became lesser. So now this, let's take 2 common, let's take x common. This is 4x minus a. So this is 2x into a, that's good. 2x into 4x, that's perfect. This is, what should we take common? 5a. And this is 4x, 5a into 4, that's good. And this is minus a, that is also good, lesser than 0. No harm in double checking. 2x into 4x, I already did that. 2x into 4x, 8x squared, 2x into minus a, minus 2ax, minus 5a into 4x, minus 20ax, minus 5a into minus a, that is positive 5a squared. All good. One more step. 4x minus a, 2x minus 5a is lesser than 0. Draw the x-axis, draw a curve, mark the values. How do you mark the values? Some people ask this question. We equate each bracket to 0. So 4x minus a equals to 0, 4x is equals to a, x is a over 4. And 2x minus 5a equals to 0, 2x is 5a, therefore x is 5 over 2a. So this is 1/4 a, that's a small value. This is the big value, which is 5 over 2a. And we are looking for the region that is below the x-axis, that is this one single region. So therefore x lies between, this is too bright, hurts the eye. This is x lies between 5 over 2a and 1/4 a. No need to draw, we cannot even draw a curve. Let me double check the answer. So this is question number 9. X lies between two values. So let's go over here. And question number 9, that's right over here. Let me just copy this. Okay, so let me paste it over here. Okay, now what are they saying? They are saying state or imply non-modular inequality or corresponding quadratic equation or pair of linear equations. That means the plus on the left, plus on the right, negative on the left, negative on the right, plus on the left, negative on the right, negative on the left, plus on the right. That's the concept of modulus. I think we will just stick with this thing, the squaring thing. Make reasonable solution attempt at a three-term quadratic, obtain critical values, state answer, and let me add to it the most important thing: solve quadratic inequality using a sketch. That is a must. That's the way to solve a quadratic inequality. Or the other one, obtain critical value from a graphical method by inspection by solving. I don't think so. That's a waste of time for this particular case in which a is unknown. Now comes a new type of a question. And why it is new over here? Let's see. Maybe this is new, maybe the other one is new. That is that the modulus is on the right hand side. So the new thing is modulus on right hand side. So now correct it. Modulus should be on the left hand side. X minus 3 modulus. Look at from this perspective of the modulus. x minus 3 modulus is greater than 2 minus 3x. X minus 3 modulus is greater than 2 minus 3x. Now the question starts from here. Now we are on the right footing. Now which case is this? This is case number 2. What is case number 2? Modulus of x greater than a, that's the same thing as x is less than negative a, x is greater than positive a. That is the right footing. So now I'll write, first of all, x minus 3 is lesser than negative of 2 minus 3x. That's the first thing. And let me just shift this thing a little bit to the top. And the other one is this, that is x minus 3 is greater than positive of 2 minus 3x. So either this or this. This red one is this purple one is this. That's how you will solve it. I hope everyone is clear. This is what we have studied the last time. Let's solve it. X minus 3 is lesser than negative 2 plus 3x. X minus 3x is lesser than negative 2 plus 3. Negative 2x is lesser than positive 1. This time I won't forget. X is greater than negative half. The inequality has flipped. Why? Because the coefficient of variable is negative. So coefficient of x is negative, and in order to remove it, so when we remove it, we know that inequality flips. So that is the thing. Now over here, the other thing, over here, x minus 3 is greater than 2 minus 3x, x plus 3x is greater than 2 plus 3, 4x is greater than 5, therefore x is greater than 5 over 4. Now this seems to be an issue. What is that issue? The issue is both inequalities are pointing in the same direction. So now that is the number line. The smaller value is negative half. The greater value is 5 over 4. What we obtained from the red one, that is moving to the right. So let me just draw a line like this. I'll just put an arrow. And the other one is 5 over 4. That is moving like this. So black marker, this is, let me just precision. Okay, and all good. So now over here, x is greater than 5 over 4, x is greater than negative half. Now there is a $1 million question. What is that question? Is the answer this region from here to here? Is the answer this region, or is the answer the complete region? I'm not sure. Is this the answer? Is this the answer? Or is the overlapping, or this region is the answer? I have no idea whatsoever. So what I'll do is that, let me choose this question again. I'll put it on the next page and I'll tell you what method will I apply. So first of all, I'm putting the question right over here. I'm choosing this number line from here. Copy it. And let me choose two values from here. So first of all, let me write it over here. Let me choose a value between minus half and 5 over 4. So let me choose a value 0. And let me choose another value greater than 5 over 4. Let me choose a value 2. So x is equals to 0. X is equals to 2. Let me plug in original equation. This is the original equation, or if I write it like this, x minus 3 modulus is greater than 2 minus 3x, that's also the original, the same thing. So if I plug in 0, I'll write, let me just change the color. So over here, let me choose the color purple, and over here, let me choose the color brownish. So now over here, if I solve this, if I plug in x is equals to 0, 0 minus 3 modulus, is it greater than 2 minus 3 into 0? Without the modulus, this becomes 3, this becomes 2. Is 3 greater than 2? Yes, the answer is correct. This is true. All good? If I plug in 2, this is 2 minus 3, sorry, x minus 3 modulus, which is x is 2. So this is 2 minus 3 modulus, which is negative 1 modulus, which comes out to be 1. And this is negative 3 modulus, which comes out to be 3. I'm just adding a value. 2 minus 3 modulus, is it greater than 2 minus 3 into 2? This is 2 minus 6, which is negative 4. Is 1 greater than negative 4? No. Therefore, this is false. This is the true false test. Now, what does it mean? That means the 0 over here, the 0 over here represents this region. This region is true. And 1 is, oh, actually my bad, 1 is greater than 0. This is also true. I just made a small mistake. Maybe I'm short on sleep. 1 is greater than minus 4. Yes, this is also true. So now over here, when x is 0, this represents this region. That means this part of the inequality is true. This 2 represents this region. This is also true. That means the whole line is true. Therefore, the answer is x is greater than negative half. That is the final answer for this one. So you have to apply the true and false test. Now the thing is, what if someone says, what if I pick this question up and let me solve it through case number 3. What difference does it make? Now someone says, why not square both sides? This was the issue that was raised last time, that I told you people, why not square both sides? What difference will it make? So this is 2 minus 3x, the whole thing square is lesser than x minus 3, the whole thing square. That is 4 minus 12x plus 9x square is lesser than x square minus 6x plus 9. This is 9 minus 1 is 8x square minus 12 plus 6 is negative 6x. 4 minus 9 is negative 5. It's lesser than 0. 8 into 5 is 40. And 10 into 4 is also 40. So 8x square and 10 and 4. So this is plus 4x, negative 10x, negative 5 is less than 0, 4x bracket 2x plus 1 minus 5 bracket 2x plus 1 is less than 0, 2x plus 1, 4x minus 5 is less than 0. And then when I draw a number line and I draw a curve like this, I mark the values. This is 5 over 4. This comes out to be negative half. Less than 0 means below the x-axis. So therefore the answer comes out to be x is less than 5 over 4, greater than minus half. But this was case number 1. Case number 2, x minus 3 modulus is greater than 2 minus 3x. There is a reason why we are not solving it this way. Why? Because this solution is incorrect. Why it is incorrect? The graph will tell the truth. So let's ask the graph to tell us the truth. So in order to tell us the truth, let me write it over there, 2 minus 3x and x minus 3. So over here, let me write 2 minus 3x. So this is 2 minus 3x, that's drawn. And the other one is, let me just remove this. This is x minus 3. Okay. This is x minus 3 and that's. So now let's look at this. How many points of intersection do you see? You see only one point of intersection. So again, let me copy it and let me write over there. So over here, when I paste it, okay. Now what do you see? The blue line is the modulus thing. So that's the blue line. Okay, this is blue and this one is green. And the equation is what? The equation is 2 minus 3x, x minus 3 modulus is greater than 2 minus 3x. X minus 3 modulus is greater than 2 minus 3x. X minus 3 is which color? X minus 3 is this blue color thing. And 2 minus 3x is the green color thing. And this greater sign means above. That means what is the value of x? What is the range of values of x for which the blue is above the green line? So this is blue and this is green going right over here. If we go to the right of this, the blue is above the green. So let me highlight this thing. Let me make it thicker. This blue over here, that's too thick. This is the blue thing. This is the blue thing that's right over here. And the green thing is over here. So now this value is negative half. This is negative half. So when we go to the right of this, the blue line, the modulus line is above the green line. And isn't that the correct answer? Which we obtain by the true and false method. So now the bottom line, the rule is whenever two inequalities are pointing in same direction, so what will we do? We will apply the true false method. Yes, if you want to, we can also draw sketch, but that is more time consuming. And that is why, what is the rule that we will apply? The correct rule. So case 3 is not applicable on modulus on one side only. Why? Because it might give us an extra solution which does not exist. Now someone can even ask this question, why is this extra solution existing if it's not true? Because over here, if this thing over here is going in this direction, now this thing is like this, if this thing is going in this direction, that is the extra solution which is existing. So we don't have to worry about that thing, that's a little bit beyond. For our purposes, what's the rule? If both inequalities are pointing in the same direction, then we apply the true and false test. How did we apply the test? That application is right over here. Choose a value between these two, choose a value beyond that, plug it in the original equation and check. If it satisfies both the thing, this is the answer. Maybe this part was false, this part was true, then only this would have been the answer. Maybe this part was false, this part was true, then the answer would have been between these two values. Now you people will try out these questions and then you will have a pretty good idea on how to do it. Till that time, let me first share the image, copy this down, try it out, and then based upon this working, try out the other questions. So let me just pause the recording over here. So now let's go over the solution of the other two problems which were sent to you people. That is this question number 2. So now question number 2, it says that the x minus 3 modulus is lesser than 3x minus 4. Decide on the case. This is case number 1. Modulus is on the left hand side and there is a lesser sign. X modulus is less than a, that simplifies to x lies between negative a and positive a. So therefore, I'll first write x minus 3 modulus is lesser than 3x minus 4. And then I'll split it into two things. What are those two things? The two things are actually one thing, that is x minus 3 and bracket And then on one side, let me just use the color later. On one side, I'll write lesser than positive 3x minus 4. And on the other side, I'll write greater than negative of 3x minus 4. That is how I have written it. All good, all clear? So now let's expand the left hand side. So if I expand this left hand side, this is negative 3x positive 4 is lesser than x minus 3. Negative 3x negative x. Negative 4x is lesser than negative 3. Negative 4 is negative 7. Therefore, x is greater than 7 over 4. And similarly, let me use another color. I think blue is good. If I solve this, so therefore this is x minus 3 is greater than 3x minus 4. X minus 3x is negative 2x. And minus 4 plus 3 is negative 1. Therefore, x is greater than half. Now again, we are in the same position. Both inequalities are pointing in the same direction. No need of drawing any sketches. The sketches were for explanation purposes only, and I've already used that. So now let me mark the points. 7 over 4 is bigger. And then this is 7 over 4. Let me write it properly. That's the bigger value. Half is the smaller value. Greater than 7 over 4, that is this line. So that is going to the right. And then greater than half, that is the other line going this way. Now let me just mark arrows. Let me mark circles over here. And what should I do? I should apply the true and false test. So choose a value between half and 7 over 4. So let me choose a value, let's say 1. So x is equals to 1. I'll plug in the original equation. Let me choose another value, let's say 2. X is equals to 2. I'll plug in the original equation. What is the original equation? That's right over here. And let me just copy this. So I'll just copy and I'll paste it over here. Let me plug in x is equals to 1. If I plug in x is equals to 1, 1 minus 3 modulus, is it lesser than 3x, that is 3 into 1 minus 4 without the modulus. This is negative 2 modulus lesser than 3 minus 4 is negative 1. This is 2 is lesser than negative 1. Think closely, don't hasten. Is 2 lesser than negative 1? No, it's false. Okay. Let me plug in x is equals to 2. 2 minus 3 modulus, is it lesser than 3 into 2 minus 4? That is negative 1 modulus lesser than 2. 6 minus 4 is 2. 1 is lesser than 2. Yes, that's true. Yes, it's correct. That means it's true. Now this time one part is false, the other part is true. X is equals to 2. It represents this region. So this green region is true. Let me just focus on the green color. Yes, the green color is true because it's representing 2. What about the blue region, the in-between region? 1, this region is not true. This is false. The green one is true. Therefore, what is the final answer? The final answer is x is greater than 7 over 4. That is the answer over here. Now, this is question number 2. Let me go to the mark scheme and let me show you the working of question number 2. There it is. You can see it very, very clearly. The answer is x is greater than 7 over 4. So therefore, let me just write it over here. Let me add a page. Let me write it over here. And this is all good, all clear. So that is the answer. X is greater than 7 over 4. Now, the last one, this question, which case is this? This is case number 2. Why? Because there is modulus on the left hand side and there is a greater sign. X modulus greater than a, it simplifies to x is lesser than negative a, x is greater than positive a. So now let me write it. X minus 2 modulus is greater than 2x minus 3. Write it separately. So this is x minus 2 is lesser than negative of 2x minus 3. Let me write it separately. x minus 2 is greater than 2x minus 3. I can just put a bracket over here. There is no harm in that. So now when I would solve this thing, let me just adjust my Apple Pencil. So now this is all good, all clear. So therefore this is x minus 2 is lesser than negative 2x plus 3. Just be careful. You are just opening this up on one side. You're not multiplying throughout. So therefore x plus 2x, that is 3x. 3 plus 2 is 5. X is lesser than 5 over 3. All good? So now over here, x minus 2x is greater than minus 3 plus 2. That is negative x is greater than negative 1. All good? Therefore, x is lesser than 1. Let me just double check my working. This is x, this is minus 2. This 2x goes on the other side, negative 2x. This is negative 3, minus 2 goes on the other side, plus 2. Negative 3 plus 2 is negative 1. X minus 2x is negative x. Inequality flips, greater becomes lesser. So let me just focus on this. Greater becomes lesser, and this one is lesser than 5 over 3. Again, the true and false test. So let me just make a number line. Let me write down the values. X is lesser than 5 over 3. 1 is over here. 5 over 3 is a bigger number. Let me use a red line for this, a thick red line. And x is lesser than 5 over 3. That is this red line going this way. X is lesser than 1. That is the blue line going this way. Now, let me change it. So this is x is lesser than 5 over 3. This is x is lesser than 1. Which value should I choose? Between 1 and 5 over 3, let me choose 1.5. That looks good. And lesser than 1, let me choose 0. So let me choose x is equals to 0. Let me choose x is equals to 1.5. Original inequality is right over here. Let me copy this down and let me paste it. So I have pasted it over here. Now when I choose x is equals to 0, what happens? 0 minus 2 modulus, is it greater than 2 into 0 minus 3? So this is negative 2 modulus is greater than minus 3. This is 2 is greater than minus 3. This is true. Yes, it's correct. It's true. If I choose the other value 1.5, 1.5 minus 2 modulus, is it greater than 2 into 1.5 minus 3? This is negative 0.5 modulus, which becomes 0.5. Is it greater than 3 minus 3 is 0? 0.5 is greater than 0. This is also true. This is all correct. That means not only is this value satisfying this inequality, this value, let me just change the color so that this is the plug-in value, this is the plug-in value. So not only is this in value which corresponds to this inequality is true, this is corresponding to this, this is also true. So go ahead and choose this thing. Therefore, the final answer is x is lesser than 5 over 3. Again, let's go and check it out. This is question number 7. So this is question number 2 was the previous one, and now it's question number 7. It's all good, all clear. And that's how we finish off this chapter. That is the concept of modulus. Yes, allow paste. And that's how this thing is done. So we have finished modulus equations, modulus inequality, and we have done it in 3 classes. So lecture 2, that wraps it all up. See you in the next class.